This is a video for the Geometry E section of the Geometry module. In this video we are looking at area. Now area is the amount of space in a shape. To find the area of combined shapes, we need to separate the shape into regularly shaped parts. We need to find the area of each part, and then we need to add together the areas for the various parts. Now it may be necessary to subtract areas from the total area to find a remaining area. Okay, so remember, it doesn't have to be adding, you can subtract. Now the formulas for area of the variety of shapes are provided in the textbook under the Geometry E section. You need to spend some time learning these formulas. Units are very important with area. Area is measured in square units, so you're looking at square millimetres, square centimetres, square metres, etc. Also, the unit of hectares is used for area calculations. All measurements should be in the same units when performing calculations. And here are some common conversions that would have been covered in Transition Maths 1, and they're also provided in your textbook. So let's look at some examples. In here we're going to find areas of the following shapes. So the first one is a square. So the area of a square is simply the side squared, which is going to be 6 squared, which is 36, and it's meters squared. Okay, part B is a circle. Formula for the area of a circle is pi r squared. Now here I have the diameter is 10, so the radius must be 5. So we've got pi times 5 squared, which is 25 pi, which is approximately 78.5 centimeters squared. Next we have a rectangle. Area is length times width. Now my units are in different measurements here. I've got 30 centimeters and 0.4 meters. So 0.4 meters can be converted to 40 centimeters. So now I have 40 times 30, which is 120, and we're in centimeters squared. Okay. Triangle. Area of a triangle is half times base times height. So half times the base is 7 times the height is 8. That gives me 28, and we're in millimeters squared. Here we have a composite shape. So what I like to do here is label the areas. So here it's A and B. You might want to use A1 and A2, it's up to you. So area of A is a rectangle, so length times width. So that's going to be 20 times, now this 7 here is just for that distance there, so it's the radius, so all the way across is 14. So it's 20 times 14, which is 280. Area of B is half a circle, so area of a circle is pi r squared, but we only want half, so we're going to divide that by 2. So now we've got pi times 7 squared divided by 2. 7 7s are 49, so 49 times pi divided by 2 gives me approximately 77 centimeters squared. So my area in total is area of A plus area of B, which is 280 plus 77. Now it's approximate because this was approximate. When I plug this in my calculator, I should still have this 77 in my calculator. That's what I'm going to use. I'm not going to use the approximate answer. I'm going to use what I had originally, but I get 357 centimeters squared to the nearest centimeter. Part F. Okay, this is your area here, and you can see that a semicircle has been cut out of it. I've already labelled A and B. So area A is a trapezium. So area of A, and a trapezium is half H A plus B. So a half times the height, which is 6.5, and A plus B is 10 plus 18.4. And that gives me 92.3 there. For the circle, so area of B is pi r squared divided by 2. Now, radius in this case is 5 millimeters because it's half the way across. So pi times 5 squared divided by 2 gives me approximately 39.3, and area total is going to be area of A minus area of B, which is 92.3 minus 39.3. Still approximate because this answer was approximate, so it's approximately 53 millimeters squared. Okay. Next, a page 29 by 21 centimeters has margins of 2 centimeters top and bottom and 2.5 centimeters on the side. So I'm going to draw a picture to help here. So it's 21 centimeters by 29 centimeters, and I have a margin happening such that this distance here is 2 centimeters, 2 centimeters, and the sides is 2.5. Okay, now I keep reading the question. What is the area of the page that can be covered by printing? Well, that would be this area here. Okay, so I'm going to label the outside area area 1, inside area area 2. So area 1 is length times width, so 21 times 29. I just figured out you could do this a different way as well. But anyway, we'll keep going with this way. So 21 times 29 is 609. We don't actually need to do it this way. Okay, so what we need is we need these distances here. Okay, if the whole thing is 29, this is 2 and this is 2, so 29 minus 4 is 25. This distance across here, or this length, the whole length is 21, and I need to take 5 away from it, so 21 minus 5 is 16. Okay, so now we can come back, and the area for printing is going to be length times width, which is 16 times 25, which is 400 centimeters squared. Worded question, worded answer. Therefore, 400 centimeters squared can be covered by printing. Okay. Next. A triangle has an area of 8.4 hectares. Its base is 560 meters. What is its perpendicular height? Now, it doesn't really matter what the triangle looks like. So just draw a picture. Its base is 560 meters. And we don't know its height. Okay, but we do know that the area is 8.5 hectares. Now, you have to convert hectares into meters, and there's 10,000 square meters to hectare, so it's 84,000 square meters. Area of a triangle is half times base times height, so that means 84,000 has to equal a half times 560 times whatever my height is. So 84,000, half of 560 is 280 h. Divide both sides by 280 and you get that h equals 300 meters. So therefore, perpendicular height is 300 meters. Okay. Last example. This one says, how many tiles 45 centimeters by 25 centimeters would be required to tile a floor 9 meters by 7 meters? Again, you've got different units happening, so it helps to convert to the same units. If I've got a floor 9 meters by 7 meters, that means this is 900 centimeters and this is 700 centimeters. Now we're assuming we can cut these tiles up. Okay, if that's the case, then we don't need to worry about how they fit. So the area of a tile is length times width, So 45 times 25, which is 1,125 centimetres squared. The area of the room is 900 times 700, which is 630,000 centimetres squared. So your number of tiles is going to be the area of the room divided by the area of a tile. 630,000 divided by 1,125, which is 560 tiles. Now note, we're assuming, we have an assumption here that the tiles will be cut. Okay, that wasn't the case. We'd have to make sure look at how our tiles would fit across the room. Okay. What now? Geometry E1 in your textbook has exercises on area.